Welcome back, builders and developers. Let's jump right into today's explainer because we are tackling a fundamental truth of modern security. We spend countless hours architecting these incredible applications, but here's the harsh reality. One compromised password can burn the whole thing to the ground. Passwords are, well, they're necessary, but they're absolutely no longer sufficient on their own. So today we're going to look at how to construct a truly secure authentication fortress. We're breaking down everything you need to know about multi-factor authentication, or MFA. All right, let's dive into the blueprint for keeping your users safe.
And if you're wondering why we even need to build this fortress in the first place, just look at this number, 99.9%. Microsoft pulled data from literally billions of authentication events, and they found that deploying multi-factor authentication blocks an incredible 99.9% of automated account compromise attacks. I mean, that is not some marketing exaggeration, that is hard data. Google's internal research backs this up too. They found 0 account takeovers among users who utilize security keys. MFA is the ultimate defense against credential stuffing and password reuse. It just stops automated attacks cold, mainly because time-limited one-time codes simply can't be replayed at scale.
So here's our game plan for today. We'll start with number 1, beyond the password. Then 2, the MFA arsenal. Number 3, implementation and architecture. 4, the recovery weak link. And finally, number 5, smarter adaptive security.
Kicking things off with section 1, beyond the password. Let's define what true MFA actually is. Multi-factor authentication basically means requiring 2 or more independent factors to verify an identity. And these factors fall into 3 distinct buckets. First up, you have knowledge. That's something the user knows, like a password, a PIN, or an unlock pattern. Then you have possession, something the user physically has, like their phone, a hardware token, or security key. And finally, there's inherence, which is something the user inherently is, like a fingerprint or a face scan. Now, if you use 2 of these, boom, you've got 2-factor authentication. 3 or more, that's multi-factor. But here is the absolutely crucial core rule. These factors must be completely independent. If you ask a user for 2 passwords, you haven't built a fortress. You've literally just put 2 cheap locks on the exact same flimsy door. You've got to mix and match from these distinct categories.
Moving right along to section 2, the MFA arsenal. Let's look at the actual defenses we can deploy.
First up in our arsenal is TOTP, or time-based one-time password. You definitely know this one. It's the engine behind apps like Google Authenticator or Authy. The way it works is actually pretty brilliant. During setup, the server generates a random secret, usually a base 32 encoded string, and shares it with the user via a QR code. From that point forward, 0 network connection is needed. It's just a beautiful piece of offline math. Both the app and the server take that shared secret, combine it with the current Unix timestamp chopped into 30-second intervals, and extract a 6-digit code. It securely generates these codes independently on both ends without ever needing internet access after that very first setup.
But we need to have a quick reality check here. SMS-based 2-factor authentication is actually highly vulnerable. What a lot of folks think is super safe has actually been deprecated by NIST as an out-of-band authenticator. Why? Well, because SIM swapping attacks have literally exploded. An attacker just uses social engineering to convince a phone carrier to transfer a victim's number to a totally different SIM card, and suddenly they're intercepting all those one-time codes. Plus, the SS7 telecom protocol itself has known vulnerabilities that allow for message interception. Now in the other corner we have WebAuthn, also known as FIDO2. This is the undisputed gold standard. Unlike TOTP, which can theoretically still be phished if someone gets tricked into entering a code on a fake site, WebAuthn is completely origin-bound. The whole authentication ceremony is cryptographically tied to your specific website's domain. It uses public key cryptography where the private key never, ever leaves the user's device. So it basically makes phishing mathematically impossible.
Another really popular weapon we have is push notification 2FA. This is where an app just sends a push to your registered device and you tap approve or deny. It's incredibly user-friendly, right? And it provides rich context like exactly where the login attempt is coming from and the browser being used. But there's a catch. It risks something called MFA fatigue. Attackers will literally just spam a user with approval requests at 2 a.m., crossing their fingers that the exhausted user accidentally hits approve just to make their phone stop buzzing. To fix this, modern implementations force the user to do number matching. So they actually have to type or match a number displayed on their computer screen to the one in their mobile app to authenticate successfully. It stops that automated spamming attack dead in its tracks.
Okay, section 3, implementation and architecture. Let's actually build this checkpoint. Let's look at a concrete example using Python. Implementing TOTP is wonderfully straightforward if you use the PyOTP library. First, you generate a strong random base 32 secret, and it is absolutely critical that this secret is at least 128 bits. Then you create a provisioning URI and display it as a QR code for your user. During login, you simply validate their submitted code using a verify function, which, by the way, even handles clock drift for you. But listen up, because here is the absolute critical trap so many developers fall right into. Step 4. Remember that the TOTP secret is symmetric. The server and the app need the exact same secret to make the math work. This isn't like passwords, which are hashed one way. If your database gets breached and these TOTP secrets are just sitting there in plain text, the second factor for all of your users is completely 100% compromised. You have got to encrypt that symmetric secret at rest. Otherwise, you've just handed attackers the master key to the fortress. Building the actual enrollment flow requires a really strict sequence of events. Think of it like a highly secure handshake. Step 1. Verify the current session. The user must be fully authenticated before you even let them think about enrolling a new factor. Step 2. Display that QR code for their authenticator app. But step 3 is where you cannot just trust the user blindly. You have to mandate that they enter a valid code from their app right then and there before you confirm the setup. Once they prove it's working, step 4 is generating those single-use backup codes. And finally, step 5, it's highly recommended to invalidate any existing sessions on their other devices, just in case their account was already partially compromised while they were setting this up.
That brings us to Section 4, the Recovery Weak Link. Let's talk about guarding the back door.
So here is a really uncomfortable truth about this impenetrable cryptographic wall we just built. Your account recovery process is often the weakest link in your entire authentication chain. I mean, if an attacker can bypass all this MFA just by calling customer support and guessing a few public record security questions, your entire expensive MFA implementation is completely meaningless. Support agents naturally want to be helpful, right? But that helpfulness is exactly what attackers exploit through social engineering. An attacker doesn't need to break your encryption if they can just sweet-talk a well-meaning agent into hitting the reset button on the MFA.
So, how do we actually secure this weakest link? First, remember those backup codes we generated back during enrollment? Treat them exactly like passwords. Never, ever store them in plain text. You've got to hash those 8 to 10 backup codes using strong algorithms like bcrypt or Argon 2-IDE. And the moment one is used, invalidate it. Next, you have to require multiple identity verification signals for recovery. Please do not rely on just a single email. And most importantly, impose strict time delays on recovery actions. Think about it, an immediate recovery is an absolute gift to an attacker. By enforcing a 24 to 72-hour delay and loudly notifying the user across all their communication channels about the attempt, you are buying the real user the most valuable security asset in the world: time. Time to react and stop a hostile account takeover right in its tracks.
Finally, we arrive at Section 5, Smarter Adaptive Security, adding context-aware checks to the mix.
The thing is, not all authentication requests carry the same amount of risk, and this is where adaptive MFA comes into play. It acts like a smart guard, analyzing behavior and risk signals in real time. Say a user logs in from a known device at their usual location. That's low risk. In that case, maybe just the session token is totally sufficient. But what if they suddenly log in from a new IP address halfway across the world at an unusual time of day? Well, that's medium risk, and you immediately trigger a step-up MFA challenge. And if they attempt a high-risk action, like changing the account email or trying to wire funds, you trigger mandatory reauthentication. Adaptive MFA is basically the holy grail here. It allows you to add friction only when it's absolutely necessary, creating the seamless user experience without compromising even an ounce of security.
As we're constructing all of this, we really have to avoid some common pitfalls. A massive one is accidentally allowing MFA bypass through hidden API endpoints. Seriously, don't build a giant fortress wall only to leave a hidden API tunnel running right underneath it. If your mobile app calls a different endpoint that accidentally skips the MFA check, your security is totally shot. You also have to remember to invalidate old sessions whenever MFA settings change. And never, ever skip MFA for a so-called trusted device unless you have a genuinely secure device fingerprint. By the way, if you're building an application that handles personal or financial data, the OWASP Application Security Verification Standard makes the rules crystal clear. Under ASVS Level 2, MFA is absolutely mandatory for all sensitive operations, not just that initial login. It is just not optional anymore.
So, I want to leave you with a scenario to test your own blueprint. Imagine you are tasked with designing the account recovery flow for a new banking application. What 3 specific security controls would you put in place to prevent an attacker from bypassing your MFA entirely through social engineering? Think back to our discussion on time delays, multi-channel verification, and instant notifications. Ask yourself, right now, how secure is the backdoor to your system? Because at the end of the day, a fortress is only as strong as its weakest gate. Thanks for joining me on this explainer. Keep building those secure systems, and I'll catch you next time.